Hi, so we are Group 1 and we'll be talking about the historical daily weather data of 2020. So, data insights. Our dataset that we chose to work with is the daily weather for 163 countries, including the provinces of different countries from January 1st to April 21st of 2020. This dataset includes various elements such as the summary of the weather of each day, the weather icon of each day, temperature, pressure, humidity, ozone levels, visibility, precipitation, and much more. So the goal of this dataset for us was to evaluate the role of the weather factors such as COVID-19 transmission factors and enable the development of prediction models incorporating those elements. So to have a better understanding of this data, we have split the data into a training set and a test set with a distribution of 70% training and 30% test. So the two graphs shown below, as you can see, shows the distribution of 7 climate classes from the train and testing set of the data set that we just mentioned. As shown in the figures, 36% of the dataset is distributed among them as rain, while 28% is distributed as partly cloudy day, and 27% as a clear day in both training and testing. As you can see in the next slide, we have two graphs. The first graph shows the distribution of the dataset country-wise. Most of them are linearly distributed as they have 163 records for most of the countries except 8 countries that have an uneven distribution of more than 163. On the right side, we have a graph that shows us the precipitation recorded in all records for each country. On the x-axis, all the countries are shown, while on the y-axis, we have shown the total sum of the precipitation values. By comparing both of these figures, we can actually see some patterns in the classes for the weather.
After importing the data to our code, we have created a copy of the data so that it can keep the original data set intact. Before we start to work on the data set, we have created a function to evaluate the model after we have done the 3 algorithms: decision tree, naive Bayes, and artificial neural network, which is also called ANN. From the dataset, there are 5 columns of the data that are neither float nor integer. To better fit those columns to the algorithms, we have replaced those cells with different numbers. With all 3 preparations ready, we started to work on the dataset.
So the next slide that we'll be talking about is our training models that we worked with. So the first algorithm that we worked with was our decision tree, and that was actually the best performing algorithm that we worked with so far. To do that, we use the sklearn tree decision tree classifier. The algorithm makes it easy for us to read and interpret the dataset. With this algorithm, we actually got an accuracy of 98.37%, which is the highest that we've ever gotten compared to the other two algorithms that we will be showing shortly. With a decision tree model, why not we just make a binary decision tree? That's the graph that you see at the bottom left of the screen. We also decided to make confusion metrics, and why not just have a graph to represent it? So that's what a confusion matrix is for, as you can see on the bottom right of your screen. Confusion matrix allows us to evaluate the performance of the classification model. So the matrix that you see here basically compares the actual target values with those predicted by the machine learning model, which in this case we use decision tree. This gives us a good view of how well our classification model is performing and what kinds of errors it is making, as you can see in the figure to the right. So in the next slide here, we'll be talking about the second algorithm that we worked with, which was naive Bayes. To use naive Bayes, we use the sklearn.naive Bayes to import the Gaussian NB. We know that naive Bayes has no risk of overfitting, and naive Bayes algorithm alone is quite faster compared to the other algorithms, which we thought could yield better results. But that was not the case here. As you can see in the bottom right of your screen, the graph here shows that we got an accuracy of 28.01%, which means this was probably the worst performing algorithm that we actually did so far.
For the third algorithm, we are choosing to do an artificial neural network. From the result of the comparative performance table, we can see that even though the artificial neural network is not the best performing algorithm, but in general, its performance is still very fine. By using MLP classifier to force the machine to learn the trained model of the data 100 times, and using Keras model sequential to create the ANN model, the accuracy of the model can get to 80% to 85%, which is a decent performance. From the graph on the right-hand side, we can see that the accuracy is pretty close to 1, which is pretty high and pretty nice. Of the 3 algorithms we have chosen, Decision Tree has the best overall performance, while Naive Bayes has the worst performance. From the comparison performance table, we can see that the accuracy of the decision tree model is 98.4%, while the ANN model is 96.76%. And lastly, the accuracy of Naive Bayes is 28.01%. The F1 score of the decision tree model, ANN model, and Naive Bayes are 98.41%, 96.76%, and 24.49% respectively. This shows that overall the performance of the decision tree is the best of all the 3 algorithms. The following are all the references for our project. Thank you for listening.